Alright guys, this is the test walkthrough for the Algebra 2 Chapter 2 test. So we're going to go ahead and start here at problem number 1, where we have a horizontal wall that is being kicked at a distance of 30 feet, maximum height of 12 feet, sketch a graph, and then write an equation of the parabola for it. So what's important for us to sketch a graph here is because we could have a few different places where we place these. Now we've really kind of gone over two main ones that are going to be the ones that are most beneficial for us. Either we're going to draw it so that it is centered about the origin, like that, or we're going to draw it so that it starts at the origin and kind of works its way over. Either one is going to work just fine for us, but you can kind of pick which one you want and then draw it. That's why I specifically say to sketch that graph first. So we're going to kind of label the important parts on all of these, and I'm going to do it both ways. You by no means need to do it both ways. I'm just going to show it to you so that you can make sure that the way that you're doing it is correct for whatever one you prefer. So for a distance that's 30 feet horizontally, that's going to be a negative 15 over here, positive 15 over here. It's 0 on the heights if we want the ordered pair. And then maximum height of 12 feet, so then this peak here is at 0, 12. So then if I do that starting at the 0, I always have my 0 point, which is the easy one. And then over here I'm going to have the point 30, 0. And then up here, it's halfway, which is 15, and then 12 for our height. So we're going to go ahead and set up the first one right up here. So if we do this, I'm going to plug in y is equal to a times x minus h squared plus k. I know where my vertex is. That's my hk. So I'm going to plug those in. So 0 for x, sorry, 0 for h, 12 for k. So y equals a times x minus 0 squared plus k, sorry, plus 12. So I can now pick either one of these points, my 15, 0 or my negative 15, 0. I'll typically go with the positive one because why not? So I'll plug that in for x and y, and I'll get 0 equals a times 15 minus 0 squared plus 12. Now the only variable that I have is my a, so I can actually go through and solve that out. So if I do this, I'm going to have 0 is equal to a times 15 squared, which I believe is 225. And then plus 12, and then I'm going to subtract that 12 over, so I get negative 12 equals a times 225, and then if I divide that over to reduce it, we'll have negative 12 divided by 225, which is going to be, as a fraction, negative 724, negative 4/75. Okay. So once we found the a, we're basically done. We just have to write it out in the actual form. So I can take this and I can plug it back into here where I still have my x's and my y's. So I would have y is equal to negative 4/75 times x squared, because I don't need that plus 0 in there, plus 12. Now if I were to do this one here, I would get the exact same a. I might just I would just have 0 minus 15 instead here. But I would get y is equal to negative 4/75 times x minus the 15 squared plus 12. So again, either one of those answers is correct, depending on which way you drew your actual graph. All right, for 2 and 3, we're being given some criteria here, and we're going to try and write the equation for it. So quadratic, so that is x to the second power. It's been shifted to the right 3, down 4, vertically stretched by a factor of 3. So that would be, this right 3 is telling me that my h is 3. This down 4 is telling me that my k is negative 4. And this vertical factor of 3 is telling me that my a is 3. So that would just be y is equal to 3 times x minus 3 squared minus 4. Over here we have a cubic function. So we're going to be shifted left 5 and vertically compressed by a factor of 0.4. So that means that that 0.4 is going to be my A, which is going to, since that's less than 1, that's what's going to cause it to be compressed there. And then, I mean, left 5 means that my H is a negative 5, so it'll H would be a plus 5 inside of the parenthesis. So I'm going to have Y is equal to 0.4 times X plus 5 to the third. Now you still want to be able to do this for any of the other types of parent functions. So square roots, absolute values, rationals, and exponentials as well. So down here to 4, 5, and 6, I'm going to try and sketch a graph of these. So on these, what I care about is the shape right and is the locator point right. That's what I'm looking for. So here, this is being shifted to the left 1. And then it's going to be, this 2 is going to make it vertically stretched by a factor of 2. So I'm actually going to be over here with a vertex at negative 1, 0. And that's going to be where it would normally go over 1 and up 1 on both sides. It's going to go over 1 and up 2 because it's going to be kind of doubling, so it's going to be a little bit taller. And then I'll kind of draw it like that. Again, what I'm looking for when I'm grading these are just 2 things. Is your shape right? Is your locator point right? So hey, my vertex is in that right spot. It's going up and it's a little bit thin. We're good. If you drew it up but like crazy wide, that's me saying, well, you probably tried to make it wider as opposed to making it taller, which is saying you don't know what it's doing. I'm not going to go there and measure it, make it go. It's not double the heights and stuff like that. Just try and have the general right shape for it. Number 5, we got a shift of right 3 and up 4. So 1, 2, 3, 1, 2, 3, 4. There's where my new inflection point is. Now a standard x to the third is going to go up and over like that, and then I'll go left and down like that. So again, I don't care specifically about the points, but I have the right shape and have that right locator point. Typically, if you just put a big dot there, makes it a little bit easier to say, hey, they know where they're actually putting that locator point. And over here on 6, this plus 3 means that we're going to be going to the left 3, and minus 1 means down 1. So from here, left 3, 1, 2, 3, down 1. There's my new locator point. Now, locator points on rationals are a little bit different because that tells you where the intersection of your horizontal and your vertical asymptotes are. So there's my horizontal asymptote. Here's my vertical asymptote, right? And then if x put with rationals, we get these kind of like corner shapes. It'll follow like that, and then it'll follow like that. So again, is my graph perfect? Heck no, right? But does it have the right general shape? Yeah, I have the rational shape graph. It's actually being stretched twice as tall, so which is a little bit harder to kind of visually see on rational graphs. But I do see that I have that locator point there in the correct spot. Okay, so if we go to the back page here, so we have trying to find all solutions here. Now, this is the big problem that most people make on this problem is they try and FOIL this out, distribute the 3, move the 27 over, and then try and factor it. That will work, but that's going to take you a whole lot of time. There's a whole lot of places for you to make errors. These ones are actually very, very easy if you just try and isolate your exponent first. So I'm going to try and get that x minus 1 squared by itself. So to do that, I just have to get rid of that 3. So I'm going to divide both sides by 3. 27 divided by 3 is going to give me a 9. So I'm going to have x minus 1 squared equals 9. And then I can square root both sides. And I get x minus 1 equals plus or minus 3. You need that plus or minus because, again, if you're the one who is putting that square root into the problem, you need to have that plus or minus on it. Then I'm going to have that minus 1. I'm going to add 1 to both sides to get rid of that. So now x is by itself. So I get x is equal to 1 plus or minus 3. Again, you could put the plus 1 on the end, but with that plus or a minus, we typically like that to be on the end. So I just kind of transposed the order there. So my 2 solutions are just 1 plus 3 and 1 minus 3. So 1 plus 3 gives me a 4. 1 minus 3 gives me a negative 2 as my two solutions there. So again, drastically easier when you do it that way, and way less places for you to make a mistake. So make sure you're solving it out in that method. That's why I gave you that one, to make sure that you can solve it from that graphing form. All right, so then we're trying to use completing these squares to write this in that graphing form. So if you still like drawing those pictures, by all means do it. If you feel more comfortable with that shortcut, use the shortcut too. That's fine. I'm going to draw the picture just to kind of make sure that everyone has at least a method in which they can do it. So x squared, and I have my one big x squared over here. And I have 8 negative x's, so I'm going to put 4 on this side. 1, 2, 3, 4, and 4 on this side. 1, 2, 3, 4. And then right in here is where I need everything else. So I currently have 3, so I have 1, 2, and 3. Right, so I'm short 4, 8, 12, 13. I'm short 13 of these. So I need to add 13 to balance it out, but I then have to subtract the 13 in order to make sure that I'm not changing the actual problem. So then this gives me my perfect square of x minus 4 by x minus 4. And then I'm going to have that minus 13 still on the end of it. So that would factor into y, or not factor, sorry, y equals x minus 4 squared, because that takes care of this whole box. Then I have the minus 13 still on the end, because that's what I had to do there to complete it. So there we go. Right? And again, if you like doing that with the actual kind of shortcut, more algebraic method, that's totally fine. Keep on doing that. I just wanted to make sure that everyone has at least a method in which they can do this. All right, down to 9, 10, and 11. So we're using these 2 points to answer these questions. So first we're going to try and find the distance between these 2 points. So to find the distance, if I look at if I treat it like it's a triangle, again, it doesn't matter, it's a right triangle here. My x distance, I'm going from -1 to 3, so that's a change of 4. So my x distance is changing by 4, right? And my y distance is going from 4 to 8, that's a change of 4. So I can do Pythagorean theorem here. A squared plus b squared equals c squared. It is also a 45, 45, 90. So if you know those rules, you can shortcut and say, well, then the answer is 4 rad 2. But we're going to do Pythagorean theorem just in case it's not that way in the future. So if I do 4 squared plus 4 squared equals, let's call that x squared. That's 16 plus 16, which is 32. Equals x squared, and then I want to square root that 32, which is going to be not perfect. So we're going to have to go, I can pull out a 16 and a 2. So I can then get 4 rad 2 out of it. There we go. Okay. All right, now we're trying to write the equation of a line that passes through both points. So we first want to find the slope here. So that's my, to find my slope, that's my y2 minus y1 over x2 minus x1. So we're going to do 8 minus 4 over 3 minus a -1, which makes it a plus 1 there. So that gives us 4 over 4, which is 1. And then I can plug that into either one of these points into point slope form. Y minus y1 equals m times x minus x1. So then I'm going to do the 3, 8, because why not? So that's y minus 8 equals 1 times x minus 3. So then we'll get y minus 8 equals x minus 3, add over the 8, y equals x plus 5. And there's other ways in which you can do that, but you're going to get, oops, you couldn't see that minus, that is equal to 1. There's other ways in which you could do that, but you'll still get the y is equal to x plus 5. So however you do it, you typically want to find a slope and then use that slope and then one of those like points to get to find your equation for it. Right, then lastly, we have a system. Okay, so these systems, we can either do them with the addition method or we can do them with substitution, whichever one we think is going to work out better for us. So looking here, nothing's going to cancel out if I do addition right now. To do substitution, I would probably want to get like either this y or this y by itself, or maybe one of the x's. It's going to be kind of nasty if I do that, but I do see that my x's are pretty darn close. If I double my bottom equation, then my x's cancel through addition, so I'm probably going to want to do that. So I'm going to multiply my entire bottom equation by 2 and get negative 16x minus 12y equals 12. I'm going to cross off that so I don't accidentally use it again. And now I'm going to do addition. So if I add down, I get zeros on my x's, which is what I want because I want one of my variables to cancel out. Then my y's, I get negative 22y equals, and then 10 and 12 is going to be positive 22. So then if I divide by negative 22, I get that y is a negative 1. So there's one of my two variables that I needed. So then to find the x, I can plug this into any one of these. The one that's going to be the easiest is one that I crossed out, which is why I didn't like erase it and really scribble it out. So I plug that in for the y, I will get negative 8x minus 6 times negative 1 equals 6. So that's negative 8x plus 6 equals 6. Subtract 6, negative 8x equals 0. Divide by negative 8x is 0. Okay. So I have my x, I have my y. You want to write your answer as an ordered pair. It doesn't really matter for this particular problem, but to get us ready for stuff that we're going to start seeing more in the future, always write your answers to systems as an ordered pair. So this is the point 0, negative 1. All right, and that is it for our Chapter 2 test. So hopefully this helped out. I'll talk to you guys next time.